From a random sample of size 16, one has calculated the 95% confidence interval for mu for the mean and obtained the result 39.51 to 42.49. What are the sample mean and the sample standard deviation for the sample? Assume the population is normal. So we know that the confidence interval is given to us as from 39.51 to 42.49. So let's put down the parts that we know. So n is equal to 16. And notice that we can find easily the sample mean from the fact that we can sum up. So we can simply add these two guys up and divide them by 2. We're going to get the mean because the sample mean is precisely between the extreme values contained in the confidence interval. Right? So 39.51 plus 42.49, and then we're going to simply divide it by 2 and we will get our sample mean. Right? So that should give us 41. Right? So we already found the sample mean. That's good. Now let's find the sample standard deviation. The standard deviation of the set of sample means, or the standard error. Right? And we know that's the formula that involves s being divided by square root of n. Now notice that I'm using the s and not the population standard deviation because we don't know the population standard deviation, and also the sample size is not large enough, right? We're not using 30 and above, we're using 16. That's really small, right? So we have to use the t distribution, the student distribution, all right? And notice that we can substitute this for s being divided by square root of 4. So that's going to square root of 16. So that's going to turn out to be s being divided by 4. Okay? So now notice that the degrees of freedom, because we're going to be using the student distribution, the t-distribution table, we have to find the degrees of freedom. And we know that formula is n minus 1. So in this case, it's going to be 16 because that's the value of the n. Subtract 1, you get 15, right? So the degrees of freedom in this case is going to be precisely 15. Now 95% confidence interval. Let's talk about that. So 95% confidence interval, what does that mean? It means that the alpha level is going to be precisely 0.05. 0.05. Okay? So notice in this case, since we're talking about a confidence interval, it's a two-tailed nature, right? It's a two-tailed nature because the mean is in the middle and you go to the right side and to the left side. And the t-distribution, the student distribution, is also symmetric, just like the z-distribution, the normal distribution that we've seen before. So for this reason, we actually should be aware of that, okay? So now we have to find, notice that we're interested in alpha over 2 because of the two-tailed nature of the confidence interval, and that should be precisely 0.025. So now we need to find the t-value at the alpha over 2 level, all right, using the t-distribution table. And by the way, what is the confidence interval formula that we're going to use after we find the result for the t-value? We know that it's going to be x bar, which is going to be the sample mean, plus minus, okay, plus minus the t-value, of course, at the alpha over 2 level, multiplied by the standard deviation of the set of sample means, or the standard error. All right? Okay, so and we already found, so we need to solve for s before we need to solve for s somehow when we get the t-value, because notice that we know we already know the x bar, right? We know that is equal to 41. So we're going to get plus minus, and then this is the only unknown guy that we're going to find. And we also need to solve for s after that, right? S divided by 4. So if we find the t-value, we will be able to solve for s. And you might say, but how do we solve for s? There's no equation. We can't create the equation by using either one of these two, right? Because we know this is the formula for the confidence interval, and the confidence interval is already provided to us, right? So we can easily solve for s when we find the t and use any one of these numbers, taking note of which sign to use here for these. Okay, so how do we find the t-value? How do we find the t at alpha over 2? So notice that the alpha level is 0.05, And the t-distribution table might not be what you accustomed to see when you were using the z-distribution. Notice it's a different type of distribution table, and you have to know how to read it. The easiest way, if your distribution table shows the confidence interval, and I know that some distribution tables do not, so it depends on which one you're using. This one does show, so I know immediately I should be in this column. All right? I should be in this column. Now, how do I know I'm in this column without the confidence interval shown here? Let's say that your table does not show it. Well, you're going to go by the alpha here. Notice that you are talking about the 95% confidence interval, okay? And notice that you're going to be talking about two tails, right? You're going to be talking about two tails because remember that we said that the nature of the confidence interval is that you have to have two tails. So basically, if we have a distribution, there's an area that we're not interested in to the t-value. Let's say this is the t-value, okay? And also there's the same area, exactly the same area on the left side that we're not interested in, and that's going to be minus the same t-value, okay? Minus the same t-value that we find. Right? We're only interested in this shaded area, and that's the confidence interval, right? And the mean, of course, is going to be right in the middle at the peak, right? That will be the x bar, the z value pertaining to the x bar, of course, right? So we need to be aware of the two-tailed nature of the confidence interval. So that's why we're talking about two tails. And notice that the two tails together make up the alpha, right? Because recall that the alpha is 0.05. Now each of these tails, of course, is going to be 0.025, right? Because that's the alpha over 2, all right? And this is also going to be alpha over 2, right? 0.025, this region here. So together, if you add these up, you get the alpha level of 0.05. And that's precisely the two-tail meaning behind the second row here. And of course, we need to find 0.05, and that's where we are. You see, that coincides with the same. That is the same column that we used, that we found using the confidence interval indication on the bottom, right? It's the same column. It's just a different way of finding it in case the confidence interval is not shown on your table, right? So you can use the knowledge of the alpha and finding the right row. Now notice if you're trying to say, but what about the one tail? Well, the one tail makes sense as well, because notice that the one tail corresponds to the probability of 0.025, like I just showed, right? If you divide the total alpha, which is these two regions, in half, you're going to get 0.025. And that precisely matches the t-value at the 97.5th percentile, 97.5 percentile of this distribution. But you have to be aware that doesn't mean that it's going to be a 97.5% confidence interval, because don't forget that we're also subtracting the 2.5% on the left side that is not part of the confidence interval, right? So notice that this yellow thing corresponds to 95% of the area, right? The 2.5% on the left, 2.5% on the right. So that's precisely what you see in the one tail explanation, 2.5% or 0.025 in value. So in any case, this is where you need to be. Now, the next thing is to figure out where in this column is your value, right? Now that you found the right column, where in this column is the right value that you need to copy down? Well, that's where the degrees of freedom comes into play. Notice that we found the degrees of freedom to be what? We found it to be precisely 15, right? So if we're in this column, we're going to find 15, and that's going to be this one right here, this row. So we have to go along this row, and we have to find the value at which the row 15 and the right column that we should be on coincide, right? They both stop at this number, 2.131. Right, so we know for sure that the value is 2.131 for this t, and it's going to be minus 2.131 on the left side, the t here. Okay, so that's precisely what it is. And notice that we can just use the positive one. We don't have to worry about the negative one when we're talking about writing the formula, because there's a plus minus already. Even if you write the negative t value, negative 2.131, you will still be fine because there's a plus and minus. So you can just write the positive, and that will still make sense for either one of these values that you're going to use to solve for s. All right, so now let's use the 2.131. And we're going to get what we need. I recommend just using the positive, the right side, the extreme right side of the confidence interval. So I'm going to set 42.49, right? So that's the missing piece that we found in order to solve for S now here. So 42.49 is equal to 41. Now notice I'm not going to use minus because I'm interested in the t-value to the right side. Right, to the right side of the x bar, the sample mean. I'm interested in the extreme value of the confidence interval, the right-sided limit basically, right? 42.49. That's why I'm not using the minus, I'm going to use the plus. And I'm going to use the positive t-value, of course, right? Because if I use the negative, I will be basically at 39.51 and I will be wrong because I set 42.49. So I have to use the positive t-value if I'm going in the right side. Right, so I have to use 2.131 and not negative 2.131, just so that you know. Positive 2.131 times the S being divided by 4. So basically, it's going to be relatively easy to solve this. You just have to do some algebra, multiplying both sides by 4 to get rid of this 4. But don't forget to multiply the 41 by 4 as well. Otherwise, you're going to get a wrong answer. But basically, you should get 4 times 42.49. Minus 41, and then divide this whole thing by 2.131, and you should get your S value. And your S should give you 2.79680901. So to the nearest 10th place, of course, or 1 decimal place, you're going to round it to be 2.8. All right, so this gives you precisely what you were asked to find in this problem, the sample mean and also the sample standard deviation. Thank you so much for watching. See you in the next video.